Bonjour, bonjour. Nous voici à la section 35, qui est un projet d'authentification de pratiquement 3 heures de temps. Mais je pense qu'on va finir ça en 2 heures, pratiquement 15 ou 30. Allons-y.
All right, guys, welcome to a brand new module. And in this module, we're going to tackle the topic of authentication. And it's something that is often thought of as incredibly complicated, but it doesn't have to be. And we're going to take it step by step from beginning to end so that you get an overview of the entire process of setting up authentication from scratch. So, why do we need to authenticate? Well, as we're creating our website or web app for users to use, then these users are going to start generating data in the website. They might like certain posts, they might interact with other users, there might be messages created or recipes created. There's always going to be some user data created. And in order to associate those pieces of data with individual users, we need to create an account for each user. So they would sign up to our website using a username and a password, and we would essentially create kind of like an ID card for them to uniquely identify them on our database and to save all of the data that they generate onto that account. So the next time that they come back onto the website, they'll be able to use their username and password and log in to our website and be able to access all of those possibly private pieces of information. So this way you don't end up with everybody being able to see, what private messages you're sending around on Facebook or see your direct messages on Twitter. So that's pretty simple. Now, the other reason why you might want to add authentication to your website is to restrict access to certain areas of the website depending on the status of the user. So, for example, if you were Spotify or Netflix and you charge a subscription for accessing certain parts of the website, then once the user pays, you have to update their account in your database to say that they have paid and they'll be allowed to access the TV shows or songs that they're entitled to. Those are some of the reasons why you might want to add authentication to your website. But authentication can be done in a number of ways. Creating a website where we sign up and log in users seems simple enough. But the difficult part of authentication comes from how secure you're going to make your website. And we're going to tackle this problem of authentication by going through the different levels of security. So we're going to go from very basic, creating an account, adding the user to our database, saving their username and password to enable them to log in, all the way up to covering things such as OAuth and social logins, including creating things such as sessions and cookies and hashing and encrypting passwords. And it's going to be more than you'd ever want to know about this topic, but it's really, really important that you learn it in the beginning because later on, once you've understood and you've built authentication from the bottom up, then I'm going to show you some ways of simplifying and making your life easier using third-party libraries like Passport. So we're going to learn how to progress from essentially a website that's basically secured with a Cheeto to something that is a lot more serious and more consistent with industry standards of good security on a website. If you're not interested in learning how to authenticate users from the very basics all the way up to the most complicated, if you just want to skip ahead right to the end where we cover OAuth using third-party social logins such as Google or Facebook, then feel free to do that. But I strongly, strongly recommend that you follow along the entire tutorial, not only because there's some pretty good jokes coming up, if I might say so myself, but also because it will help you build a foundation of knowledge around this topic so that when you see it in the wild, you won't be stumped. Once you're ready, we're going to get started building a website that keeps secrets. Makes sense, right? Authentication. There is a app called Whisper that you might have come across, and it's a really simple concept. Basically allows people to submit their secrets anonymously. So whatever they post are not associated with an email or a username, and it means that people can express themselves, I guess, more freely. It's quite a fun website, and this is what we're going to try and replicate by the end of this module. So the structure of our website is really, really simple. It has a homepage, which has two buttons that allows you to either go towards register or go towards login. And once the user has been registered or logged in and they have been authenticated, then they are able to access the secrets page. So I've kept the remainder of the website pretty simple because we're going to be focusing on a pretty complex topic. So I've created some starting files for you to download so that we can focus our efforts on learning authentication and not get distracted by things like Bootstrap and styling. Once you're ready, head over to the next lesson, and then we're going to get started with our level 1 security authentication. So I'll see you there. Hey guys, in this lesson, we're going to be introducing you to level 1 authentication, and we're going to be seeing how we can allow users to register and log in to our website by allowing them to enter an email and password. This is the most basic way of authenticating a user on our website, and it is also the least secure, but we've got to start somewhere, so that's what we're doing. If you take a look inside the course resources for this lesson, you will see a zipped file that you can download and extract as usual. And once you've extracted it, you should be able to open it inside VS Code, and it's called 9.1 Authentication Level 1. I want you to take a look inside this folder and see that I've already created a package.json, including all the pre-required Node npm packages. And inside the index.js is going to be our starting file. As usual, we're going to start by seeding into this particular project folder. And once we're here, we're going to run npm I in order to install all of the required packages. And there's not that many. It's just body parser, EJS, Express, and PG for our database. If any of these are new for you, then it might mean that you have skipped some modules before. So when we talked about EJS or Node or database, and it's important to know that I'm going to assume that you've watched those lessons and you're comfortable with working with Postgres database, you're comfortable with working with EJS templating, Node, Express, all of that, because I want to cover some new content in these lessons in this module. But if you have just skipped straight into this module, just be aware it's probably not going to make sense. And I strongly advise you to do the entire course from beginning to end, even if you do it at 2x speed and just complete all of the exercises and projects. That way, at least you'll know that you're on the same level as everybody else starting this lesson. So once we've run our npm install, then the next step is to go ahead and start up our server. So I'm going to use nodemon and go into our index.js. And once our server is up and running on port 3000, I'm going to go over to localhost 3000, and here you will see our website. The website is a pretty simple bootstrapped website where we have just two buttons on the homepage. So this is the homepage. We have a login button that takes us to a login page, and we have a register button that takes us to a very similar looking register page. So I've tried to keep everything else super simple just so that we can focus on the most important things. Now, if you look inside the views folder, you'll see that we've got our partials, we've got our homepage login register, but there's also another page called secrets.ejs. And this page is super simple. It looks pretty much the same as the other pages. It's just got an H1 and a paragraph element that has some sort of secret that the user can only access once they have authenticated themselves on our website. This is the page that we're trying to prevent unauthorized access to. And we're going to render it only when the user has registered and logged in. You'll notice in the index.js, I've already included the bare bones of this website, so you should be able to simply just get it up and running. But if you take a look at the routes, you'll see that the get routes don't need any work on our part, and it's also super simple, just render homepage, render login, render register. But in the post routes, these are the two routes that we're going to be working on in this lesson in order to allow the user to post a request to our server to register themselves and post to our server to log in once they've done that. If you look inside the register or the login page, they're actually exactly the same with respect to this. You'll see that this is the section that makes the post request. This is our form. Notice the action of the form. So this is the route that it's going to hit up in our server. Notice that it's got a method of post. So it's going to be submitting the data from the form, and that there are two inputs. One has a name of username and the other one has a name of password. So those are the things that we're going to have to target when we use our body parser to grab hold of the text that the user enters. Now, if you scroll down, you'll see some commented out code in here. Don't worry about that. We're going to deal with this in another lesson, and we're going to try and keep this simple for now. So leave all the code inside the views folder as it is, but just be aware of what the name is for each of these fields so that you know how to get hold of it in the app.post. Okay, so first challenge is to go into the app.post under the register and the login routes, and I want you to be able to console log whatever the user enters into the username field and the password field. Make sure that these lines of code work both in the register and the login routes. So to do this, you're going to have to review what you learned previously regarding body parser. Now notice I've already included the app.use for our body parser middleware. And of course, as you might remember, Express already includes that. So if you wanted to use the Express version of URL encoded, feel free to change this code. But I recommend just to keep everything as it is and look inside the register.ejs and secrets.ejs to figure out how you can console log the username and password both on the login screen. So if I was to click login, I should be able to see that console log down here instead of a error. So at the moment it's obviously undefined, but you're going to fix that very shortly. So pause the video and give that a go. All right, so this shouldn't be too hard. All we need to do is to create a const, which in this case I've decided to call username, and we're going to tap into it from request.body, and then the final variable name depends on how it is we named it here. And notice both in register.ejs as well as login.ejs, they're called username and password. That means we can say request.body.username, and do the same for request.body.password. And I can simply copy and paste these two lines into our login. And now if we go ahead and open up the terminal down here, you should be able to see, if I go back to this website, go back to the login page, click the login. I've already got my values pre-filled, but feel free to type yours in. If we go down here, you can see we've got the username and password printed out. And it should work exactly the same way for register, and you'll see that printed out as well. You'll see that my password is pretty simple, 123456, and I've got the email here as well. So if you manage to complete that, go ahead and delete all the console logs, and we're going to rename this from username to email. Now notice not this part, because this comes from the form, just this part, and this is helpful so that we actually can mentally differentiate which part is from the EJS form and which part is going to be used in our post request. So we've got the user's email and password. The next step is simply adding that into our database when they register. So we're going to add the user into a new database called users. I'm going to save their email and password so that when they come back and try to log in, we're going to check their password against the user with a particular email. And that's basically the logic of how we can verify a user in the most simple way using our Postgres database and our Node backend. If at this point you feel like giving yourself a challenge because you do in fact have all the skills already from our database section to be able to implement this, then go ahead, pause the video and try and do it yourself. Don't worry if it doesn't work. Don't worry if you get stuck. You can always come back. I'm always going to be here to run through the code with you. But just as an added challenge, it might be good to try it as a starting point. The rest of you who are following along with me, the first thing, as you can imagine, that we need to do is to set up our database. If you look inside the file called queries.sql in this folder, you'll see that I've already added a query in here that allows us to create the table that we need. It's got a ID as the primary key, as usual, and then we've got our email and password, and I've set them as varchar. Email has some additional modifiers. It cannot be null and it has to be unique so that each user has a unique entry. And I've left the password relatively easy. Feel free to add any other modifiers you want based on what you've learned in the database section. But otherwise, we're going to copy this query and go into our pgadmin. And firstly, we're going to create our database. So right click on databases, create our database, and I'm going to call it secrets. And I'm going to go ahead and hit save. Now I have my database called secrets. I'm going to click on the query tool to be able to paste in the query that I want to run, which creates a table called users inside that database with these three simple fields. Now let's hit run. And hopefully you'll have query returned successfully. So now if we take a look inside that database, inside schema, inside tables, and you go ahead and click refresh, you should see that we now have a users table. And we're going to view all rows, and you'll see that right now we just have an empty header. This is where we're going to be entering our users' details when they register. We're going to save their email, save their password. The ID is auto-generated, and we'll be able to use it later on when we need to check them when they log in. Coming back to our index.js, the first thing we need to do in order to connect to that database that we just created is to import PG from PG. So that was the module that has already been installed from our package.json. And this allows us to work with our Postgres database from Node. And then the next thing we're going to do is we're going to connect to that database. So this is the code that we usually use. And remember, I named my database secrets. As you can see right here, I gave my database a starting password of 123456, which was created long ago when we set up Postgres. My username is Postgres and the host is localhost. And again, we've explained all of this to great lengths and in great detail in the database section. So I'm not going to talk about this anymore, other than the fact that we are now creating a new database connection and then we connect to it. And once we have done that, then we are ready to start registering some users. We know that we can get hold of their email and their password through these two constants. Can you figure out how to insert the email and password into our users table using a PostgreSQL query? And once that's done, then go ahead and render the secrets.ejs. Pause the video and give that a go. All right, so this is what the code should look like. All right, so this is what the code should look like. We are making a database query, which has this particular SQL code. We're inserting into our table called users, and the values that we're inserting is email and password, which corresponds to the values $1, $2, which is inserted here as an array. You can go ahead and console log the result to see if it was successful or what happens, but in most cases it should work and we should be able to simply go ahead and res.render our secrets.ejs. Let's go ahead and try that out for real. Let's try and register this user, angela@gmail.com, with my password. And you can see that firstly I get taken to the secret.ejs file showing the secret page, but also if I go into my PG admin and I right click and view my users, you'll see that I have a new row of data corresponding to what it is I just inserted. Now, there's a bit of a problem here though, because what if we try to register a user that already exists? Because right now, if I click register, I'm going to get an error. And if I go back to my file, you'll see that the error is because I'm trying to insert a row that has a duplicate key value because we have a unique constraint on the email field, which you might remember from this line here. It has to be not null and it has to be unique. So by trying to insert the same email in a different record in that table, I end up tripping this. And this is quite an important one for us to trip. It's not wrong that that happens. It just means that we need to handle it. So how do we handle it? Well, I'm going to wrap this inside an if statement. So instead of simply just straight up inserting, I'm going to first check to see if I already have that user in my users table. So select all from users table where email is equal to $1. Email is of course the one that they entered in the field. And then if the check result.rows.length, if that result comes back with a value, then that means I already have a user with that email. So I can simply do something like res.send or render a different page or create a little pop-up or a little message, something that I can handle on the front end to tell the user, hey, you're already registered. Maybe you can try logging in. An alternative flow that you can consider when you're making a more complex website is you can simply just log them in yourself using a code by taking their email and password. But the important thing here is we first check, and if they already exist, we perform some sort of action. If they don't exist, then we insert them into our database. And that unique constraint is quite important so that we don't end up doubling up on users with the same email but different passwords because they try to register multiple times. That is something to be aware of, and this code will catch that out. One final thing I recommend doing is actually wrapping all of the queries inside a try and catch block. And the reason for this is because whenever we're working with PG, things might not work. We might not be connected to the database, or we might have lost connection, or the database might be gone, or it might not be at the right address, or we might not have the right password. But it's a good idea to try and catch these, and if there are any errors, to either console log them or to handle them appropriately. That concludes the entire section we need to do to register a user. The next part is figuring out how we can check when a user enters their email password, check them against our database. So find the user with this email, see if they exist. And if they don't exist, then we tell them you haven't registered. But if they do exist, then we check their password that they entered here in the form against the one that we had saved in our database. They match, we let them go through to see the secrets page. And if it doesn't match, then we tell them it doesn't match. So see if you can use what you've learned about Postgres databases in previous modules to complete this functionality. Thinking about what we talked about in the register route, such as the try catch, such as checking the result, whether it exists, etc. So pause the video, give this a go. All right, so let's run through the solution code. First thing we do is we wrap everything inside a try-catch block. Then we make our database query. The first query is we're going to select everything from the users table where the email is a match for the one that was entered in the form. Now, once we get the result back, if there is a result, if the user does in fact exist in our database, then that means they have previously registered in our database. So that means that the result.rows at position 0 should contain all of the data of that user. And in fact, you can actually simply verify this by console logging that. So if I console log result.rows and hit save, go to the login route, which is where we've got our console log, try to enter that email and password, go back over here and check what gets printed out. You can see that it's an array and there's only one row that matches that criteria because, of course, the emails are unique. And the first element in that array is the object that contains the ID, the email, and the password of that user. So what that means is we can then set the user to result.rows 0, and that is going to be equivalent to this object right here. And then we can set the stored password, so the password on our database, to user.password. Finally, all we need to do is check if the password, which is the entered password, matches the stored password. And if it does, we're going to render secrets.ejs. Otherwise, we're going to tell them incorrect password, or we're going to redirect them back to login, or we're going to give them a flash message, whatever it is you want to do. But this should be handled separately. And also, this other else statement is here because it catches the cases where result.rows.length is 0, which means that no user was actually found in our database using this email. That means that the user's not found, which could mean they're not registered or they registered with a different email. But either way, you want to handle that by telling the user what is going on. There you have it. We now have a login route and a register route. We save our user's email and password into our database. We check their saved password against the password they enter when they try to log in. And if the passwords match, then we show them the secret page. This is not bad because it works, but it's also not great because you can see the user's password right there in plain text in our database. So that means that if somebody hacks into the database, if somebody manages to get this data, then every user's password is matched against their email, and this bad person will be able to know that user's email. And they might use that email across multiple websites on the internet, and it could be a really bad thing for them. So this, while it works, and it is the most basic level of authentication, is not enough. So in the next lesson, we're going to cover the next level of authentication, where we talk about encryption, salting, hashing passwords, all of the important things that makes this more secure for our users. So for all of that and more, I'll see you on the next lesson. In the last lesson, we looked at the most basic level of authentication, which is simply through the use of an email and password. And as we saw, this is perhaps a little bit lacking in security when we can very easily go into our database and see any user's password in plain text. This is very, very bad practice. Every so often you might hear in the news a website or a company is somehow hacked and all their users' information is leaked into the wild. So you might have heard of the Ashley Madison hack or the Experian hack, but lots of these websites end up being prosecuted, in fact, and may have to pay a fine for not storing their users' data in a secure fashion. So it's not just about angry users. There are also legal implications, which is why we need to think about these things very carefully. If storing a user's password as plain text is the worst possible way of securing it, I mean, it's not to say that this is immediately going to lead to problems, because if you're a normal user accessing the website and you try to view page source or look through the code on the front end, you won't be able to find anything because those things are stored on our backend, on our servers, and the database isn't easily accessed. But still, there is enough precedent where this has happened, and we need to think about securing those passwords more carefully. That leads us to the topic of encryption, which is something you might have heard of already. It's defined in the dictionary as the process of converting information or data into a code, which can also be called a cipher. And the main reason is to prevent unauthorized access so that people can't view that sensitive information easily. A really simple example of a encryption is something called the Caesar cipher, which is named after Julius Caesar. This is an extremely simple form of cipher, where we take the alphabet and we have an encryption key. So let's say that the key is 4. What this means is we shift the letters by 4. So that means that A becomes 1, 2, 3, 4. It becomes E. So then the alphabet looks something like this. That means if a user tried to type the secret, which they wanted to encrypt, and this equaled ABC, when this is encrypted using the Caesar cipher, then it becomes EFG. Then this part is transported, or it is stored on a database, or it is, in Caesar's case, put into a letter and passed through enemy territory. And once it reaches the other end, because the recipient knows what the encryption key is, they can then go back through that process and take each letter and reverse it through 4 steps in order to end up with the original message, which is ABC. You can try this out yourself on a website called Crypty, and you can see how you can take plain text and write something like hello. And once you get the code or the ciphertext, you can see it has been automatically shifted by 4 in this case. This is the encryption key, and this is the important part that hopefully the recipient already knows. So you can change this as much as you like, and you can see that just by somebody looking at the ciphertext, they might think this is a foreign language. They might not know what the actual answer is. But, of course, there is a very simple way of decoding it by simply taking that key, that shift amount, and applying it to the ciphertext. We've already looked at encryption, so taking the user's password and securing it using an encryption key, and then using a particular cipher method, be it a Caesar cipher or the Enigma cipher or a modern cipher method like AES. No matter which way we chose, we always had a password, a key, and we ended up with some ciphertext, which will make it hard for people to be able to immediately guess what our user's password is. So for example, if we took a password like QWERTY and we used the Caesar cipher method and we decided to shift it by 1, then our encryption key is the number 1. And that creates the ciphertext where every single letter is shifted up by 1. Now, in order to decrypt this, all you have to do, as long as you know what the key is, then you can simply shift all of the ciphertext down by 1 and you end up with the original password. The Caesar cipher is a very, very weak encryption method. It's incredibly easy to figure out what the original text was, even if you didn't have a key. And just to illustrate what bad things can happen when you have a weak encryption system, I'm going to tell you a story from history that tells us why we should not be using a weak encryption system. So, back in the 1500s, on this island that we now call the United Kingdom, there used to be 2 large areas. One was Scotland and the other was England. And they were ruled over by 2 queens. Scotland was ruled by Mary Queen of Scots, who was a Catholic, and England was ruled over by Queen Elizabeth I. Now, these 2 ladies between them controlled the land that we now call the UK, but they each wanted to have more power and more land. So, what did they do? Well, Mary Queen of Scots, who ruled over Scotland, decided to plot with her friend, Lord Babington, to try and assassinate Queen Elizabeth. That way, she would be the legitimate heir to both the English and Scottish throne, and it was kind of a Game of Thrones kind of situation going on back then. But in order to mobilize their forces or try to come up with some sort of secret plan, they decided to send letters to each other using ciphertext. So they came up with a system to encrypt their letters to each other, such that if it fell into the wrong hands, the subject of the letter wouldn't be revealed and they wouldn't end up being tried for treason. But the problem was that the encryption method that they used, which was a letter substitution method similar to the Caesar cipher, was a very weak form of encryption. And Queen Elizabeth had a chief decoder who ended up deciphering their letters and figuring out what their encryption key was. So he decided to take this encryption key and write a letter back to Lord Babington to try and get him to reveal all of the co-conspirators. And what was the end result of having their weak encryption system? Well, Queen Elizabeth decided to accuse Mary Queen of Scots of treason, and hence she ended up having her head chopped off. So this is not what you want to happen to you or your website. So weak encryption systems can end up putting user passwords at risk, and your company might end up metaphorically decapitated, such as in the case of companies like TalkTalk or Equifax, where they ended up getting hacked and lost a lot of the trust of their users. Now, if you're interested in more stories like this and to learn more about cryptography and encryption, there's a really great book recommendation I would make called The Code Book by Simon Singh. It contains stories like the one that I just told you and more. So if you're interested in this, go ahead and read more about it. In modern days, we use something far more secure, which is called AES 256. And this has a whole bunch of math applied. But at the end of the day, the essential process is still the same. We have some plain text, and then we have an encryption key, which is something that you keep top secret and you don't pass along with your text. And we can go ahead and encrypt the string using AES. You can see that the result is much, much longer. It's very hard to work out how many letters the original text had. But if you were somebody who's meant to receive this message and you receive it, and then you know that the encryption key is, for example, in this case, top secret, then you can easily decrypt it into the original message. Now, there is just one weakness to this situation if we're thinking about storing passwords, and that is the fact that this type of encryption or this type of obfuscation is symmetrical. So it means that if somebody happens to get hold of this super important encryption key and you encrypt everything in your database using this particular method, AES 256, or no matter how strong it is, if they get hold of this particular thing, then everything else collapses. And they can work out everybody's secret, they can work out everyone's password by simply decrypting it using that same key, which is not what you want. How can we make our password more secure? At the moment, the biggest flaw in our authentication method is the fact that we need an encryption key to encrypt our passwords and decrypt our passwords. And chances are that if somebody is motivated enough to spend time and hack into your database, then it's probably not that difficult for them to also be able to get your encryption key, even if you've saved it in an environment variable or somewhere secure on your server. So how can we address this weakest link, the need for that encryption key? Well, here is where hashing comes into play. Whereas previously with encryption, we needed that encryption key, hashing takes it away and no longer requires the need for an encryption key. Well, then you might ask, well, if we don't have an encryption key, how can we decrypt our password back into plain text? Well, the secret is you don't. Let's say a user registers on our website and they enter a password to register with. We use something called a hash function to turn that password into a hash, and we store that hash in our database. Now, the problem is that hash functions are mathematical equations that are designed to make it almost impossible to go backwards. So it's almost impossible to turn a hash back into a password. How is this possible, you might ask? How is it possible that you can turn a password into a hash very quickly and easily, but make it almost impossible to turn that hash back into a password? Well, here's a question. Let me ask you, what are the factors of 377 other than 1 and 377? So basically I'm saying 377 is not a prime number. Not only can you divide 377 by 1 and 377, but there's also two other numbers that you can divide it by. Now it's your job to figure out what those numbers are. So what might you do? Well, you might divide it by 2. Okay, so that becomes 188.5. That's not a whole number, so 2 is not a factor. What if you divide it by 3? Well, that becomes 113.3 recurring, which is also not a whole number, so 3 is not a factor either. And you might go through this process for a long time, tediously, going through number by number. Well, then you might arrive at the point where you divide 377 by 13 and you end up with 29. So 13 and 29 are the answers to this question. They are the only factors of 377 other than 1 and 377. And as you can see, that process of getting to this point, of finding those two factors, took us a while, right? It wasn't that easy. But consider if I asked you a different question. If I said to you, can you multiply 13 by 29? Well, you would be able to do that really quickly and easily. It would take you almost no time at all to figure out that the answer is 377. So here is a very, very simplified version of a hash function. Going forward, multiplying 13 by 29 is really quick and easy. But going backwards, trying to get back those numbers 13 and 29, starting from 377, is very, very time consuming. This is essentially how a hash function works. Just add a little bit more complexity and you end up with a real hash function. They're designed to be calculated very quickly going forwards, but almost impossible to go backwards. And by almost impossible, I simply mean that using current levels of computing power, it would take far too long to make it worthwhile for the hacker. So let's say that to calculate the hash going forwards, it takes a millisecond, but to go backwards, it takes 2 years. Then that hacker probably has better things to do with his time. So when a user tries to register on our website, then we ask them for the registration password, which we turn into a hash using our hash function, and then we store that hash on our database. Now, at a later point, when the user tries to log in and they type in their password, then we again hash that password that they typed in to produce a hash, and then we compare it against the hash that we have stored in our database. And if those two hashes match, then that must mean that the login password is the same as the registration password as well. And at no point in this process do we have to store their password in plain text, or are we able to reverse the process to figure out their original password. The only person who knows their password is the user themselves. Now, hashing also comes along with its own problems though, because as soon as you come up with a problem, then some motivated hacker will come up with a solution. And in the next lesson, I'm going to show you how we can hack our users' passwords. So for all of that and more, I'll see you there. All right, guys, so now that we've covered creating user passwords, encrypting our database, as well as hashing passwords, we've kind of reached a level of security that most websites are at. Now, there's a lot more security that we're going to learn about a little bit later on. But you're actually at a point where you already know quite a lot about authentication and keeping user passwords secure, and definitely a lot more than a lot of people who actually run websites. And I know that some of you guys are keen to get a job, and if that is you, then I want you to go onto a website called plaintextoffenders.com. I'll link to it in the course resources. But here, what you'll find is emails that come from various companies where the user is requested to reset their password, and they're sending the user a plain text version of their password. Now, at this point, we know to be able to even get the user's password in plain text, it means that they're doing some horrible things with securing the passwords. Either it's encrypted and there's an encryption key somewhere that they're storing, or it's simply just stored on their database as plain text, which is the worst possible type of security. Given that you already know a lot better than the people who run getlinuxjobs.com or worldsim.com or Telecom Egypt, then you could actually just email these people and tell them that I'm a web developer and I know about authentication and securing users' passwords. You obviously seem like you might need some help. Would you like me to work for you? I recommend giving that a go if you're keen on getting a job. If you're not looking for a job, then have a look at these websites. And if you're signed up to any of them, be sure to delete your account because it's definitely not secure. And this is why a lot of companies and a lot of websites get hacked, because they don't continue beyond this point. So that means it's a really good time to talk to you about how passwords are hacked. So a sort of hacking passwords 101 class, if you will. Now, most of the time I use my programming powers for good, but in this case, I want to talk to you about how passwords might be hacked so that once we understand how the other side approaches this problem, then we can learn more about security and make our website safer for users. And by the way, I have no idea why hackers are always portrayed in a balaclava. It's not like they're going to burgle anybody. I mean, especially this guy, he must be incredibly warm sitting next to all these computers, wearing so much clothing on his face. But I digress. as a company, this is probably one of the things that you least look forward to. The day when you wake up and you get a call and you've been hacked. And this has happened really recently to a lot of big companies, like Adobe Creative Cloud got hacked in 2013, LinkedIn got hacked in 2012, and there's loads of accounts where their passwords get leaked. Lots of unhappy users who reuse their passwords and are feeling extremely vulnerable. And you can see that even to this day, people can purchase these hacked accounts where people might not have realized that their LinkedIn email and their passwords are linked, and people are potentially buying that data up and using it to hack into their PayPal accounts or other similar payment portals. So even if you don't learn anything from this lesson, I recommend just going to this website. I'll link to it in the course resources just for educational purposes, but put in your email address and make sure that if you do have any passwords that show up, change all the places where you use that password. But why is it that all of these big companies are getting hacked and leaking their users' passwords? Are they not at least encrypting or hashing their passwords? Well, they are. But consider this. So you're a hacker and you've managed to get into the LinkedIn user database. And just for simplicity's sake, let's say it looks like this. You've got a username and you've got a hash. And thankfully, they didn't store their users' passwords in plain text, so you can't access their passwords straight away. However, if you look at this table a little bit more closely, you'll realize that 3 of the hashes are completely identical. Now, why might that be? Well, remember that the same password always turns into the same hash, no matter how often you try it. And that's a core part of the hash function that we rely on in order to validate our users as well. So that means a hacker would look at this table and realize that Angela, Tony, and Emily all have the same password. And what they can do is they can start to construct what we call a hash table. So you would take some of the most commonly used passwords and you would use the same hash function to create the hash value for each of those. And these are some of the most common passwords that people love to use. 123456, QWERTY, password 111111. And so you generate this hash table, and then all you have to do is just look up the hash of the user and compare it against the hash you have in your table. So you search by the hash value and you land upon the password, which is QWERTY. So now you figured out that 3 out of 4 users in this table all have the same password, and it's QWERTY. So what if they didn't use one of the most common passwords and instead they use something else, say their date of birth or their pet's name? Well, let's see how we would make a hash table if we were a hacker. You would probably start with all the words from a dictionary, and this is where the term dictionary attack comes from. You create hashes from all the possible words in a dictionary, and that will only be about 150,000 hashes that you would need to create. And then you add to that hash table all the numbers from a telephone book and all the combinations of characters up to 6 places. And then you add all of these together and you end up with something close to 19.8 billion combinations, which admittedly sounds like a large number, right? How long would it take your computer to calculate that many hashes? So what do? Well, let's go shopping. Let's go and buy some of the latest GPUs or graphics cards, which are capable of parallel processing and therefore are particularly suited to not only Bitcoin mining, but also generating hashes. With one of the latest GPUs, you can calculate about 20 billion MD5 caches per second. So that means with our hash table of 19.8 billion combinations, it'll only take one of these GPUs 0.9 seconds, which is nothing. It's not a lot of time to invest in order to hash so many people's passwords. And to make it even worse, large hash tables have been built for the most common passwords. So because we've had so much data from previous hacks, such as the Adobe one or the LinkedIn one or TalkTalk or Equifax, we know what the most common passwords are that people use. And every year, companies like Splash Data will compile what are the most common passwords, say the top 25. And this is where all of those values that went into our table came from. But you can actually go one step further. There are pre-built hash tables that people have created for the top 10,000 most common passwords. And you can see that MD5 is one of the quickest hashes to calculate. And this is why it's very, very common to find MD5 hash tables. And you can even use Google as a basic hash table. You can paste in the hash that you found from the hacked database, you perform a simple Google search, and you come up with the original password. If at this point you're extremely scared and you're wondering, well, what exactly can you do about this? Well, consider that in our user table, there was one hash that was extremely difficult to find, and it didn't match up with any of the hashes in this little simple hash table we built. So what if we put that into Google to search on a larger scale and see if it matches any of the hashes in the hash tables that people have generated? And it doesn't. It doesn't match anything. And the reason is because when John created his password, he had a very, very strong password with uppercase letters, lowercase letters, numbers, symbols, but most importantly, a long password. When you think about hashing as a mathematical formula, you'll realize that as the number of characters of your password increases, the computation time that it takes to crack it increases exponentially. So it doesn't matter if your account on LinkedIn or Adobe Creative Cloud or Ashley Madsen was cracked, as long as you had a strong password, they wouldn't be able to work it out from a hash table. As an example, there's a website called Password Checker, and you can put in your password and it'll tell you not only the strength, but also how long it will take various types of machines to be able to crack that password. So let's say that I create a 6-character password composed of a random set of characters, right? 1, 2, 3, 4, 5, 6. And you can see that even for a standard desktop PC, it only takes about 3 seconds to perform a brute force attack to crack that password. But let's see what happens if I add another 6 more characters. 1, 2, 3, 4, 5, 6. Now it takes 31 years for a standard desktop PC to be able to crack it. And even a fast GPU takes 2 years to crack my password. So even though all of the websites encourage you to add a capital letter, a lowercase letter, some numbers, and some random characters, if you only have 6 characters in your password, so a short password, it still doesn't take very long to crack. So the most important thing of creating a strong password that is almost uncrackable is just to increase the number of characters. And also, to prevent yourself from being a victim of a dictionary attack, just make sure that you don't use a dictionary word or a place name or something that is in a directory somewhere, like a telephone number. Alright, so at least after this lesson, you'll know how to keep yourself more secure. But in the next lesson, we're going to address these vulnerabilities that occur because of weak hashing algorithms, and we're going to learn how we can combat hackers who try to attack our database using a dictionary attack or by creating a hash table. So for all of that and more, I'll see you on the next lesson. But as a quick bonus, if you ever want to trick your friends into thinking that you're some sort of a hacker, at least according to Hollywood, I recommend checking out a website called hackertyper.net, where you can just mash the keyboard and you end up with something that looks extremely realistic. But word of warning, try not to do this on an airplane or in a government building unless you want to actually get investigated. All right, so now that we've seen what some of the vulnerabilities might be for hashed passwords, it's time to level up and learn about a way that we can prevent these types of dictionary attacks or hash table cracks. And in order to do that, we have to learn about salting. Now, what exactly is salting? Well, we already know what hashing is. It's when we take a password, we run it through a hash function, and we end up with a hash that we store on our database. And as we saw in the last lesson, passwords that are generated by humans are extremely insecure. They tend to be very short, and they tend to be dictionary words that are extremely easy to look up and create a hash table for. Now, salting takes the hashing a little bit further. In addition to the password, we also generate a random set of characters. And those characters, along with the user's password, gets combined and then put through the hash function. So the resulting hash is created from both the password as well as that random unique salt. So that means no matter how simple the password of the user is, adding that salt increases its complexity, increases the number of characters, and we make our user database a lot more secure. Consider the previous problem that we saw in the last lesson, where we covered Hacking 101. Now, we know that 3 of our users have the same password, and we figured that out because they all had the same hash. Now, on the other hand, if we had generated a random set of characters, which is the salt, and combined the password with the salt in order to generate the hash, then they won't have the same hash in our user database. So let's try and generate Emily's hash from her password. So we know that her password is QWERTY, and we generate a random salt. So then let's go ahead and put in her password, QWERTY, and then we append at the end that random salt that we generated, and we end up with a hash. Now, this hash, however, is not the same as Tony's hash, or we append at the end that random salt that we generated, and we end up with a hash. Now, this hash, however, is not the same as Tony's hash or Angela's hash because the salt is different each time. Now, the salt is something that the user doesn't have to remember, and instead it's stored in the database along with the hash. So that means when the user types in their password when they try to log in, you combine their password with the salt, and if you generate the same hash, then they must have had the same password. It's kind of clever, isn't it? And on our database, of course, we wouldn't be storing their passwords, but only the salt and the hash. Now consider our previous statistics. You can generate about 20 billion MD5 hashes per second. So even if we added a salt and we made it harder to generate a hash table, with some of the latest GPUs, you can still probably generate a hash table with all salt combinations relatively quickly. So what else can we do to increase the security? Well, we can use something other than MD5, right? Another hashing algorithm that's valued because it's incredibly slow. And this is where bcrypt comes in. This is one of the industry standard hashing algorithms that developers use to keep their users' passwords safe. Because while you can calculate 20 billion MD5 hashes per second, even the latest and the greatest GPUs can still calculate only about 17,000 bcrypt hashes per second, which makes it dramatically harder for a hacker to generate those pre-compiled hash tables. And a salted hash table, instead of taking something like 3 seconds if it was hashed with MD5, if it was hashed using bcrypt, it would take you something like 8 months, which is not really worth a hacker's while. They'll probably go and search out a company that has less security enabled. And to make our passwords even more secure when we're using bcrypt, it has a concept of what's called salt rounds. How many rounds you're going to salt your password with. And obviously, the more rounds you do, the saltier your password. And also, the more secure it is from hackers. What exactly are salt rounds? Well, let's say that our original user password was QWERTY, and we generate a random set of characters as the salt. So now we have QWERTY and a random set of salt. We pass it through our hash function, bcrypt, and we end up with a hash. Now, that's one round of salting. If we wanted to have 2 rounds of salting, then we take the hash that was generated in round 1 and we add the same salt from before. And now we run it through bcrypt, the hash function, again, and we end up with a different hash. And the number of times you do this is the number of salt rounds. Now, the reason why this is genius is because as computers get faster, remember that Moore's law says that every year the number of transistors in a computer chip almost doubles and the cost of that faster computer halves. So every year you can get more computing power for less money. And this is where salt rounds comes in. When you're hashing your passwords using bcrypt, you can set the number of rounds you want to salt your password. So that means maybe this year in 2019, you salted 10 rounds, but maybe next year you can increase that number to 12. And for every increase in that number, the amount of time that it takes to hash your password doubles. And so that means you don't have to change your hashing algorithm or update your code other than simply changing one number to keep up with the times. So just to review, coming back to that user database, we'll have each user's username stored, we'll have their randomly generated salt stored, and then we'll store their hash after a set number of salting rounds. And when it comes to checking their password when they log in, we'll take the password that they put in, combine it with the salt that's stored in the database, and run it through the same number of salting rounds until we end up with the final hash. And we compare the hash against the one that's stored in the database to see if they've entered the correct password. Let's give that a go in real life and implement bcrypt and salting rounds into our website's authentication. The package that we're going to be using to hash our passwords using bcrypt is also called bcrypt, and you can find the documentation for it, as always, on npm. Now, let's try and apply this knowledge to our project and add hashing and salting into our password storage and make it a little bit more secure. Go ahead and download and extract the project file for this lesson. And once you have extracted it and open it in VS Code, it should be 9.2 Authentication Level 2. Take a look inside the index.js. You'll see that we have all of the code that came from the solution code at the end of the previous lesson. So there's no hashing or anything happening here just yet, and we're going to implement that very quickly. Take a look inside the package.json. You'll notice that there is a new dependency added, and that's bcrypt. Bcrypt is a way for us to be able to hash our passwords using the Blowfish algorithm, which is a super secure, very modern way of ensuring that nobody with current computational skills should be able to decode our password in a reasonable amount of time. It is something that is industry standard, and we're going to use it in our project. As always, first of all, cd into the correct project, and then use npm install to add all of the node modules. All right, so the first thing we need to do is to import that bcrypt module. So import bcrypt from bcrypt. And one thing we should define before we start using it is the number of salting rounds. So we'll call that salt rounds, and I'm going to set it to 10. It depends on your own individual sort of level of security you want for your app. But obviously, as we explained, the more rounds of salting that happens, the more computation and more time, therefore, is required to try and hack the original password out of the hash. So if we only did 2 salt rounds, it would take less time to generate the hash, but it would also probably allow some bad actors to be able to figure out the original password by brute forcing a lot quicker. So we've imported bcrypt, we've added our number of salt rounds. The next thing we're going to do is to actually use it. Coming into our register post route right here, we've got all of our previous code. But now, after we check and make sure that the user doesn't already exist, and we're about to save their email and password into our database, just before that happens, we're going to do our password hashing. And we're going to do that by using the bcrypt module, and it has a method called hash. Now, this method takes a number of inputs. So the first one is the data that you want to hash, which is the password that the user typed into the form. Next is the number of salt rounds. So we already have that defined as a constant up top, which I said 10 in my case, and it works out on a couple of computers we tried to be good enough in terms of speed. And then finally, we have our callback, which can return an error. And if there were no errors, then it will return the encrypted string, which we're going to call the hash. So let's create this callback. And once we have that hash, then the next step is to store that into our database instead of the plain text password. So I'm going to take all of this code up to the res.render and put it inside this callback. Now, remember that because we are waiting on this query to complete without any errors before we render secrets.ejs, we have to turn this callback into an asynchronous method by adding the async keyword before it. So now we're ready to replace this password with the hash that gets generated here. And if there were any errors through the hashing process, then we need to either handle it, or at the very least, we need to console log it just so that while we're testing, we know what's going on. And if there were no errors, then we're going to go ahead and do the rest of the planned parts of saving that user's hash and email into our database. Let's go ahead and try this out. Let's go ahead and start our index.js, go back to our website, go to the homepage, try to register a new user. So I'm just going to call it maybe test. And then the password is still the same. It's 123456. And then I'm going to click register. So now if I go to my database and I right click on the users to view all of them, I should now have a new user, test@gmail.com, and the password, as you can see, even though, as you saw me enter it, it was still 123456, just public announcement, don't do that. Try to have a more secure password. But even though it's super insecure in terms of password, we now have a hash that's generated. It's super long. I definitely cannot tell that this is 123456, and hopefully nobody else will be able to too if we manage to do everything correctly. And that's because we did our hashing correctly. So now somebody hacks into our database, they'll see this instead of this, and it means we've made life a little bit safer for this user. I'm going to go ahead and actually delete this first entry for angela@gmail.com because it no longer actually follows our password strategy. So now every new user that gets signed up on our website will have a hash for their password. Now that we've done our registration and we've hashed our password for storage, the next step is to figure out how to compare the password that's stored in the database against the password that the user enters when they try to log in. Unfortunately, with bcrypt, because we're doing many salting rounds, each time we hash the password, it will not match. So we can't simply just compare the stored hash against the hashed version of the login password and expect them to match. There's actually an extra layer of security in there with that salting, and each time the hash that's generated will be different. How can we then compare those two passwords? Well, bcrypt actually comes with a method called compare. Right here, we're going to say bcrypt dot, and this is the method that we want to use, which is compare. And this allows us to compare the data, which is the data that is to be encrypted, so the data that comes from the user when they try to log in, and then the encrypted, which in this case is, of course, the hash that's stored in our database, and then we end up returning a callback. So bcrypt.compare, and the first one is the new password. So I'm just going to change this to login password so that we're not confused later on in our compare. So we're comparing the login password, and we're going to compare it against the result that comes back here, which I'm going to change to the stored hashed password. And that's the comparison that's going to be made. Now, the order of these two matters a great deal, so don't put this one here and that one here. It has to be this way so that the compare method knows which one it needs to work with and which one it needs to hash. And then we end up with our callback, which is going to be an error or a result. And then here, we can again handle any errors that occur in this process by console logging. And if there were no errors, then we're simply going to check to make sure that the result is valid. Then we're going to console log the result for now. I just want to show you what it actually looks like. So let's go back to our login page, use the user that has a hash password. Then we're going to console log the result for now. I just want to show you what it actually looks like. So let's go back to our login page, use the user that has a hash password. Go back to here, you can see that what got console logged is the result true, which means that all we need to do is to check if that is true, then we can go ahead and render. But if it's false, then we can again send that they got the incorrect password. And we can now delete this if and else statement here. Just to make sure, let's try that with a wrong password. I'm going to use the second worst password in the world, which is QWERTY. Click login. You can see we get incorrect password. There you have it. We've now implemented hashing and salting, and we have made our passwords much, much more secure for our users. And even if somebody hacks into our website, they will only be able to see this, and there is no way for them to be able to get back the original password that's associated with that email. And if you want to allow users to log in with email and password, we're at a stage where that's already pretty secure for the user. In the next lesson, I'm going to talk about something slightly different. We're going to talk about how to implement cookies and sessions so that when a user is logged in, they can log in to access the secret page, but that login is saved as a cookie so that they don't have to re-log in if they came back to the website, say within a certain period of time. And this is pretty common when you try to access Facebook or Gmail. You're not having to enter your password again and again each time. And we're going to be able to add that functionality to our website as well. Keep your eyes peeled in the next lesson as we learn all about that. So for all of that and more, I'll see you. Hey guys, in this lesson, we're going to talk all about cookies and sessions. Now, just a word of warning here. During the lesson, if you continue watching, you may start to feel that you get a little bit hungry. So don't blame me if I've just completely derailed your diet plan. Because in this lesson, we're going to talk all about cookies and their yummy goodness. Not really. The type of cookies that we're talking about that relates to web development are more similar to fortune cookies because they have a message that's packaged inside. And you can pass these around and they can be broken to reveal the message. You've probably come across cookies before, but if you haven't, I just want to show you how it works in practice. So let's say we go onto Amazon and we search for the Switch, right? The Nintendo Switch. And we decide to go ahead and add it to basket. So now when we look inside our basket, you can see we have one item, the Switch, right? And then we're going to do something that all e-commerce sites hate. We're going to go and navigate away and abandon our shopping cart. Now, this to any e-commerce website is a real crime because the user obviously wanted to buy something, but then at some point they got distracted by something else, abandoning their cart without checking out. So what does Amazon do? Well, as soon as you added that item to the cart, Amazon has created a cookie and has stored that cookie on your browser. So how can we go and view that cookie? Well, inside Chrome, if you go to Settings and you search for cookie, if you scroll right to the bottom, it shows you that there's something relating to cookies inside Content Settings. So if we go over there and we click on Cookies, you can see there's this option to see all cookies and site data. And now you can see that Amazon has not added just one cookie. Just by doing that very small act of adding a Nintendo Switch to our Amazon basket, Amazon has told our browser to save all sorts of information about ourselves. And if we click on amazon.co.uk, you can see there's the session token, the session ID, and these cookies don't necessarily contain any actual information, say this user wanted to buy a Nintendo Switch, but what they do contain is an ID number. And this ID will be used to fetch all of those things that you added to your cart during this browsing session on Amazon. And this is why if you decide to go and close down your browser and you open it back up, and let's head back to amazon.co.uk, you can see that my Switch is still inside the basket. So they haven't forgotten this. So that means the next time I go onto Amazon, that Nintendo Switch is still going to be in my shopping basket. However, if we go into those cookies for Amazon and we go ahead and delete it, so let's go back to see all cookies and site data. We find the one that is directly related to Amazon and we remove all of these. Now, if we go and refresh this website, you can see we forced it to forget our last browsing session and it doesn't know about that Nintendo Switch anymore. Now, on the internet, cookies are used widely to save these browsing sessions, and it goes beyond just saving your last actions on the website. When Amazon adds those cookies to my browser, it also means that when I go and visit another website, say if I go onto Facebook, then it knows who I am and what items I wanted to buy on Amazon. And it will try to remind me of that thing that I wanted to buy on Amazon. And it's kind of creepy, but this is essentially how retargeting ads work. Once a user comes to your website, initiates some sort of buying behavior, and then they decide to abandon cart, you save what it is that they wanted. And then on other websites or when they come back onto your website, you remind them about that thing that they wanted to buy. And this is all done through cookies and sessions. If we review this from a web development point of view, it means that, say on day one, when I go into Chrome and I type in amazon.com, my browser will make a GET request to Amazon server requesting for their homepage. Amazon server will then respond to that request and send over the HTML, CSS, and JavaScript files that are needed for my browser to be able to render the Amazon website. And then let's say that we decided to add a computer to our cart. Well, that is equivalent to making a post request to Amazon server, saying that I would like to buy a computer, right? And it's at this moment in time when Amazon servers will create a cookie that contains that data. This user wanted to buy a computer. And when it responds to the post request, that cookie gets sent along and the browser gets told to save that cookie. So that means that if I now get distracted and I decide to go onto Facebook or whatever it may be, but if I come back tomorrow, that cookie is still saved on my browser. The next time that I make a GET request to Amazon server, that cookie gets sent along with my GET request to allow the server to be able to identify who I am and see if I had any previous sessions on Amazon. And it's the equivalent of cracking open that fortune cookie, revealing what were the previous things that I wanted to buy. So in this case, it was a computer. And then they could respond with the HTML, CSS, JavaScript, and also render my cart so that the computer is already added in the cart. There are lots of different types of cookies, but the types of cookies that we're going to be looking at are the ones that are used to establish and maintain a session. A session is a period of time when a browser interacts with a server. Usually, when you log into a website, that's when your session starts, and that's when your fortune cookie gets created. And inside that fortune cookie, you'll have your user credentials that says this user is logged in and has been successfully authenticated. So that means as you continue to browse the website, you won't be asked to log in again when you try to access a page that requires authentication, because they can always check against that active cookie that you have on your browser, and it maintains your authentication for this browsing session until the point when you log out, which is when this session ends and the cookie that's related to this session gets destroyed. We're going to be implementing cookies and sessions into our website, and we're going to be doing it using something called Passport. Now, if you talk about Node.js and authentication, it's almost impossible to not mention Passport. And it's something that's very, very flexible and allows you to authenticate your users using either a local strategy, like what we're doing right now, which is username and password, or use a whole bunch of other services such as Google, Facebook, LinkedIn, Twitter. And it makes it a lot easier for you to be able to plug these different ways of authentication into your website. Let's get started learning about Passport and learning about how we can implement cookies and sessions. Again, in this lesson, there is an associated download, and that's a zip file that when you unzip, it should be a folder with files called 9.3 sessions and cookies. As always, extract it, open it VS Code, run npm install once you have navigated to the correct location. And you'll notice that we've added a couple of new packages in the dependencies for this project compared to last time. The first one is something called Express Session, which is the package that we're going to use to enable this kind of session persistence, which allows us to save a cookie on the user's browser. And then next time they try to access our website, we check that cookie and make sure that we can bypass that whole login process. Another tool that we're using in order to work with Express Session is called Passport. And Passport.js is a really neat library because it allows us to add lots of different authentication strategies into one project very easily. You can see that there are 500 plus strategies, and that includes a lot of the most commonly used ones. For example, if you wanted to allow people to log in with Twitter, if you wanted people to log in with Facebook or Google or GitHub or Microsoft or just a whole bunch of different strategies, you can implement Passport and you'll be able to add each one of these strategies very easily, just as if you're playing Lego. So we're going to get started by implementing something called Passport Local, because at the moment, the only strategy we have is local login, which means username and password, or in our case, it's email and password. To use it, we need the Passport module as well as Passport Local and also Express Session. So don't worry about spelling it wrong. Don't worry about typing it wrong. It's already included in the package.json. So once you do that npm install, those modules will get added automatically into your node modules folder. The code in index.js is completely the same as before, but I want to walk you through step by step how we can implement cookies, sessions, and all in the package of using the Passport Local strategy. The first thing we're going to do is we're going to import something called session from our package express-session. And this is going to allow us to set up a new session to start saving user login sessions. So we're going to use this as a middleware. So use app.use, and then we tap into the session and we create a new instance and pass in some options. What are the options we're going to add? Most important, we need a secret. And this is the secret that's used to sign the session cookie. So if you remember what we talked about encryption, this is quite important. You can consider this as the key that's used to keep the session secrets. Because we're bypassing the login process, we need to make sure that we are doing everything that we can in order to make sure that we are protecting the user's login information. You can set this to any string you like. So for example, I'm just going to call it top secret word. And in this case, you can replace that with whatever you like, just as long as you make sure you add one. Next, we're going to set resave to false. And what this option does is whether if we want to force a session to be saved into the store. The great thing about session is you can pair it with Postgres and you can save the session to your database. At the moment, I'm not going to do that. So I'm going to set this resave to false because we're going to save it in our app on our server for now. If you wanted to persist this, then you can look up how to use Express Session with a Postgres store to store it. And that means that even if your server was reset or if you updated your server and restarted it, it would still work for the user because that information would be on the database. For now, I think this should do just fine. So the final one I'm going to set is something called save uninitialized. And again, this is to do with whether or not we want to force a session to be saved to the store. And I'm going to set this to true so that we actually store the uninitialized sessions into our server memory. Now, once we've done all of that, the next thing we're going to do is we're going to use Passport. I'm going to import Passport from the Passport module, and it's really important that your Passport module goes after your session initialization. You should have already created your session before you use the next lines of code. This is really important. If you get the order wrong in our middleware, because we know it gets run from top to bottom, if you haven't got a session that you've already set up, and then you try to do the next thing, which is, again, middleware, so app.use, and then it's passport.initialize, and that requires some parentheses because it's a method, and then it's app.use passport.session. This has to happen after we already have a session that's already ongoing. Otherwise, it's not going to work. So just make sure that you've got the right order in your code as well. So now that we've done all of that, I'm going to show you what's a really cool thing that you can do because we're now using Passport and sessions. At the moment, we're deciding whether it's app.use passport.session. This has to happen after we already have a session that's already ongoing. Otherwise, it's not going to work. So just make sure that you've got the right order in your code as well. So now that we've done all of that, I'm going to show you what's a really cool thing that you can do because we're now using Passport and sessions. At the moment, we're deciding whether or not to show the user secrets.ejs, depending on whether or not they've passed either registration or login. But in most cases, you would probably want a route, right? You would want an app.get that goes to /secrets so that the user can hit up that path straight away in their URL. But this has its own challenges because how do we know if they are already logged in? Well, if we have an active session that's saved in a cookie, then we can straight away show them that page. But if we don't, then we shouldn't show it to them. The way we do this is we can use something that gets saved into the request, which is called isAuthenticated. And this comes from Passport. And it allows us to check, is the current user who's logged in the current session authenticated already? And if that turns out to be true, then we can show them the secrets page. So we can say, if this is true, then in that case, we'll res.render the secrets.ejs. But otherwise, so else, we're going to res.redirect to the login route. That way they'll have to log in first before they see this. If we go ahead and start up our server as it is, you'll see that if I try to go to that route /secrets, it's going to redirect me straight into the login page. And if you open up the Chrome developer tools, so you can either go through the settings or you can use the shortcut, which I taught you previously, you'll be able to see that under cookies, you may or may not see localhost 3000. All right, so how can we implement login for the user who we already have stored on our database right here? We saw that previously we can use their email and password to log in, but now we want to be able to authenticate that session and start it up in Passport. So the first thing we're going to do is we're going to import and then add a set of curly braces to import something called strategy. And this strategy comes from passport-local. So this is actually also known as a local strategy. Now, the next thing we're going to do is we're going to scroll all the way to the bottom, just above our app.listen, and we're going to tap into Passport and say passport.use, and we're going to use this to register a strategy. And the strategy is going to be a new strategy. So we can create a new object from this class called strategy. And inside here, we're going to call something called verify. That's a function called verify, and it takes 3 parameters: a username, a password, and a callback, which in the Passport world is always written as CB. So now we can open up our curly braces and start adding some code into this strategy. The fact that it's a local strategy means it's trying to validate whether if the user already has the right password, if their email exists in the database already. So basically everything that we've already tried to do inside our login route. So we can actually cut this entire try-catch block and we can paste it straight in here. There's one thing that we need to remember about Passport. It can automatically, through the use of this verify function, grab hold of the username and password from the form that submits the login request. So if we look in login, you'll see that there is a field called username and a field called password. And as long as that matches and we have username and password, and also username and password in the name attribute here, then what it's going to do is it's going to automatically grab it, and we can in fact confirm this by console logging this. And instead of us having to use body parser and grab hold of all of that stuff by using request.body.username, etc., body parser automates that for us. The other thing we need to take a look at is because our database queries are asynchronous, so we need to wait for them to happen before we continue, we need to change this verify function to an asynchronous function. So that's an async function called verify. And as always, how do I know all of this? Of course, it's through reading the documentation. If you go into the documentation section and you go to their tutorials and go to username and password, then you'll see that there's several sections that we can skip. We've already got a starting project. We've already got our login prompt. Now, this is where we're at the moment. We're working through this verify password section. Now, they use a different package to hash the passwords. We're using bcrypt and they're using crypto. And in fact, more projects use bcrypt in the real world than crypto, so don't worry about that. You are in good company. And we're kind of just working through this verify function at the moment. One of the important things to realize about how Passport works is it gets triggered whenever we try to authenticate a user. So it falls into this verify function. And the first thing we try to do, as we did before, is we're going to see if we have a user with the current email. And we're going to change this from email to username as well, so that we actually use the username that comes from the form. And if we do, namely the length is greater than 0, then we set them as the current user, including all of the result that comes back from the database, which remember includes things such as their ID, their email, their password hash. Next, we use our bcrypt to compare their password that was entered in the form versus the password that was saved on the system. And if that happens to be the same, so let's go ahead and change this login password to the password from here. And if that comparison succeeds, then we will end up with a result that is equal to true. Here, instead of simply res.rendering secrets.ejs, we're going to try and pass a callback. So we're going to return from this function, which is this verify function, and we're going to return by calling the callback. That's one of these inputs. And the callback is going to firstly include any errors. Well, if this result was true, then that will be null, no errors. And then the next thing we're going to pass over is the details of the actual user. We can save the details of the user from our database lookup, pass it through the callback, and that means when we redirect to the next stage, which is to go to the /secrets, in the request already, we will have the is authenticated set to true, and we even have access to something called a user. So I'm going to console log this a little bit later on, but I'm just going to write it out so that you can see what it looks like. Request.user will have the details that we have saved into it from this part where we got the user from the database and then we added the user into the callback. What if things go wrong? Well, if there was an error, instead of console logging it, then we should return the callback and pass the error here. And also, if the password was incorrect, then we should also return a callback. And in this case, it's not really an error because there's nothing wrong with what's happened with Passport or with authentication. It's actually a user error, which is not strictly an error. And here we can set this second value, the user, to false. And this basically tells us when we try to get hold of the user or when we check is it authenticated to false. And that means we know that the user is not authenticated. And then finally, we've got this last res.send, which we're going to change into the same format, return the callback, and we're going to set this as an error. We're going to set the error to user not found. And we might as well do it in case our database query goes wrong as well. That's all there is to setting up our local strategy. It basically takes it out of the app.post and puts it into a separate section which can be reused at any part of our code. The last thing we need to do is just before the app.listen, we're going to write something called passport.serializeUser. And this takes a function, so let's add another set of parentheses inside the first set of parentheses, and we get to serialize a user. So that means that we can save the data of the user who's logged in to local storage. And we can use the callback to pass over any of the details of the user. Now, there is another Passport-related method that we need just to make this work, which is called deserializeUser. And it's exactly the same code, it just passes along the user's information. And all that this does is it saves the user's information, such as their ID, their email, to the local session. And then when you want to get hold of the user, it deserializes it back into a way that you can access the user's information through that session. Coming back to our app.post, instead of handling everything inside a asynchronous function as we normally do, grabbing hold of the request, sending back a response, etc., we're actually going to ignore all of that and we're going to use Passport as middleware. So that means that straight after the comma, after the route, we're going to use passport.authenticate. And this is the method that is going to trigger the strategy down here as long as we tell it to. So we're going to say use the local strategy in order to authenticate this particular request. And what this is going to do is we're going to set some options. First is a success redirect. Where do you want to redirect the user if everything went well and they are successfully authenticated? We redirect them to /secrets. Now, what about a failure redirect? Well, if they got the password wrong, if it didn't work for any sort of reason, we're going to redirect them back into the login page. If all of that's a bit confusing, let's first just try it out. So let's hit save, make sure that we've got our server already running, and let's go ahead and make sure that this actually works. All right, so now let's go ahead and test it out. Let's go to our login page, which we have added. I'm going to put in my user with my email and password. And you can see as soon as I click login, it takes me to the secrets page, which meant everything went well. And we can actually catch that thing that I told you about, the user that got serialized into the session and then deserialized when we need to access it by tapping into request.user. We can console log it when we actually head over to the secrets page. Let's go back to our login page, click login, and you can see that request.user being printed here. It gives me their ID, their email, their password, and all of these things are stored whenever a authenticated request is made. And this also means if I try to go to the secrets route again, if I try to hit refresh on this page, or if I just go to it, or even if I close down my tab and reopen a new tab, you can see that my session is now saved. And if you go into the Chrome Developer Tools, which remember is over here, under More Tools, Developer Tools, you'll be able to go to the Application tab. And here you can see under the Cookies section that for our URL localhost 3000, we've added a cookie into here that helps us to persist this session. This is why this is saved. Now, you might be wondering, well, how long is that session saved? What if I closed down the browser and then I try to go to this again? Will that work? Well, no. As you can see, I typed it in again and it told me to log in. That's because that session cookie has now expired. So how do we set the expiry? Well, we can go into where we have our app.use and we have our session. One of the options is cookie. And the cookie can have an option called max age. And this specifies a number in milliseconds to use when calculating the expiry. If we start out with 1000 millisecond as 1 second, and then we times it by 60 to get 1 minute, and then we times it by 60 to get 1 hour, and then maybe we times it by 24 to get 1 day, then we end up with a 1 day length cookie. So now if I repeat that experiment again, let's go ahead and log in. Copy our URL and close down this browser and then put it back in here. You can see my cookie is still valid. It's still working. So that's just one thing that you can mess around with depending on what your needs are. The final thing we need to do for our session is what about the registration route? We've got this strategy for login, which is all very well and good, but right now our register route still tries to do a res.render. We can update this very, very easily using another method that we get as a part of using Passport. What we're going to change here is instead of simply just inserting the user and not caring about the results, we're going to change this to say insert into the user the new email and password, but we're also going to use that returning SQL command in order to return everything that we get back from the record that we just inserted. That means that we can actually get hold of the new user through this result of this database query. The user gets inserted and then it comes back in the result because we're using that returning function. And then we can simply set the new user to equal the result.rows, and we're going to tap into the first row. And now, instead of using res.render secrets, we're going to use request.login. which comes from passport. And remember, it is this particular login, so I is lowercase. This is important. And inside here, we're going to pass the user that we're going to save to the session. That is going to be the same as the user we created just now. And then it also allows us to add a callback in the case of what to do once everything is done. If there are any errors, it will be captured in here, and we can simply console log any errors if it exists. Otherwise, we can do a res.redirect, and we can redirect to the secrets route. And once we've called request.login, this automatically authenticates our user, passes this user's information into the session, serializes, deserializes, and when we get over here, we'll still be able to log that user. Right here, we can check if they're authenticated, just the same as when we do our login route. And I'm going to show you this by creating a new user. So let's go to the register route and let's create a new user. So I don't have this email in my database yet. I'm going to register her, goes straight to the secrets page, and you'll see that user being printed right here from this line in the app.get of the secrets route. This is a really neat way of being able to get hold of your user data at any route or any part of your server, and it's really useful when you want to check information for that user, when you want to persist user sessions, etc. Even though it doesn't add a lot in terms of security, it's a really important part of all modern websites when we do authentication that we actually persist their sessions. In the next lesson, we're going to talk about something called environment variables. And you can see even when you were creating this session, it tells you that this secret should be stored in an environment variable so that it doesn't get added to your repository. And that is what we're going to discuss in the next lesson. How we create environment variables, how we prevent them from being exposed to other people, because after all, this is an encryption key and it is very, very top secret. So for all of that and more, I'll see you then. Hey guys, in this lesson, I want to introduce you to the concept of environment variables. And again, similar to the previous lesson, this is not so much about our users, about keeping their data safe. It's more about keeping your data safe. So what do I mean by that? In the last lesson, you saw that we created session and we had to create an encryption key, a secret, and keeping that secret in our index.js, which, as you may know, is often uploaded to GitHub, or you might need to put that onto your server. Either way, that information is very, very easily leaked. It's very easy for people to crawl GitHub looking out for these secrets and API keys that they can take advantage of. And very often in the development world, you hear stories like this, where a developer put AWS keys on GitHub, then bad things happen. And it's because currently we're in a Bitcoin mining frenzy era. And to mine Bitcoin, you need a lot of computing resources. And those resources get directly turned into money, providing a huge incentive for people to scrape the internet for developers who've accidentally published their secret keys. And this is a good story as well that I'll link to in the course resources, where this guy Luke had accidentally published his API keys onto GitHub, and then he racked up an AWS bill of over $3,000 in a very, very short space of time. Now, I think the ending to the story was a happy one, and Amazon AWS actually refunded him the money, but I'm not sure everybody is as lucky as he was. These are some really cautionary tales about keeping your secrets, your API keys off the internet where it's publicly searchable and where people can steal. That's all very well and good, but how exactly do we do that? Because obviously for our app to work, we need these secrets to be able to encrypt our database. And for us to be able to collaborate with other people, or simply just using version control or backing up our project to GitHub, then we will need to publish it, right? So the way that developers solve this conundrum is through using something called environment variables. What exactly are these environment variables used for? Well, there's two major use cases. One is for convenience. Normally, when you deploy a large application, the process is quite complicated. And once you've done it, you kind of don't want to mess around with the code base and update the code files. Instead, you could have these environment variables which you can change. So certain variables that are being used in your codebase could be set as environment variables, and you can modify those variables without having to touch the code. A second reason might be for security. So when you're developing software, you might be uploading your codebase somewhere. And it's usually not a good idea to have things like your authentication keys or your API keys to be stored in the same place as the rest of your code. That's where environment variables come in. So environment variables essentially allows us to separate out where we store our keys, our secret stuff, and various other variables away from where our code base is located. Environment variables are basically a very, very simple file that we're going to keep certain sensitive variables such as encryption keys and API keys. In this lesson, I want to show you how we can do this using a really popular package called .env. And you can see just through the sheer number of weekly downloads that it is a really heavily dependent upon module to keep everybody's secrets off of the internet, safe and secure. All right, so let's get started and see how we can implement environment variables in our project and save those secrets and keep the secrets secret. Go ahead and download and extract the folder called 9.4 environment variables. And if you look inside package.json, the package that we're using to create these environment variables is called .env. If you're not already there, then stop your server, cd over to this particular module, and go ahead and run npm install to install that new package. Once you've done that, the next step we need to do in order to move this secret out of our index.js is to create a file inside this folder. So at the top level, so you can collapse the folder, open the folder, and here you're going to click on this button to add a file. Now, whereas normally files end with an extension like .jpeg or .png, in this case, we're only going to give the file an extension name, and it's .env. And if you get it right, you should see that on the left-hand side, you get this little gear icon show up. Now, if you don't see any of these icons on your VS Code, it's probably because you don't have this extension installed. It's free. We covered it at the beginning of the course, but it's called VS Code-icons, and you can add that, and it'll give you these pretty little icons to work with. So how do we move this out? Well, literally, I am just going to cut my secret and paste it into here. Now, I'm going to give it a name. I'm going to call it session_secret. And this allows us to see some of the formatting of how environment variables are added. First, we have a name for that variable, and notice how there's no constructor in front of it. There's no const or var or whatever. This is not actually JavaScript. This is just a way for us to give this piece of information a name. And everything is in all caps, and each word is separated by an underscore. And then we have an equal sign, and then we have a string enclosed in double quotes. That string is going to be whatever information is going to be associated with that name. The other thing to notice is that there's no space between the start and the end of the equal sign. And also, if you were to create another variable here, you don't have any sort of commas or semicolons or anything. You just start it on a new line. Now that we've got that, let's go ahead and save that, go back to our index.js. What do we replace this part with? Well, replace it with process, which is a Node.js process, tapping into env, which is an environment variable property, and it contains the user environment. And then we tap into the name that we gave it, which in my case was session, 2 s's, _secret. And this should tap into the environment that this current file is running in the node process, and it tries to find the one that has this particular name right here. Now, in order to add this file into that environment, we need to use that .env module that we imported earlier. So we're going to import env from .m, like so. And then we need to also initialize it. So we're going to write env.config. And this is the one where it adds the .m file contents into the process.env so that we can actually have access to it. And that's all it takes to set up an environment variable. So now if we go ahead and run our code, so we'll do index.js, and we go to our local host and we log in, everything still works exactly the same as before. And we still have our sessions persisting, etc. But we no longer have that secret right here in the index.js for anyone to read. This is useful when we start thinking about things like professional development. We would have this probably under source control. So if you go into this tab here in VS Code, you'll see initialize repository, which you can click on, which will initialize a new source control, or in this case, a new Git repository for our project. And it can persist all of the things that you want to persist. Now, this includes all of the things I have in all of the other projects, which is a little bit much, but it's essentially based on the top level. Now, what usually happens when you upload your files to GitHub or any other form of source control or something like this, you normally will add the .env file type to the gitignore, a completely separate file that's added to a gitignore list, which means that when we upload our project to GitHub or any other form of Git, it doesn't go online where it could be seen by others, which means it does not get added to Git and given access to other people to see. If you take a look at this URL or simply just search for GitHub node, the GitHub team themselves have actually come up with a list of common things that you should probably ignore if you're making a node project. And these things include things which are very large, such as any node modules, because all the dependencies added together is a ton of code. You don't want to be uploading, downloading that. That's why I always get you to do npm install, just to get used to the practice, even though we're downloading through zip files. But in the future, if you're working on open source projects, if you're working in a company, you're very often going to be pulling data from a GitHub repository or pushing data to GitHub. And it's important that you don't end up uploading this up and down all the time. Now, the other thing that you'll see in here, which makes sense for us, is our .env files. So you can add other types of .env, so you can specify one which is just for local development, one which is for production, local, etc. But the one that we care about the most is pretty much the bog standard .env. And this is also ignored for Git, which is important. So let me just demo to you what this actually looks like. So I'm going to copy this file, and I'm going to create a new window where I'm going to create a new project. So here's a brand new project. Let me just go ahead and create something. Let's say we cd to the desktop and I make dir create git env test. And we go into that. So open that folder. And we open it in our VS Code. Let me just create something code not so secret.js. And then inside here, we can have whatever it is we want. I'm just going to have some text in here. And then I'm going to add a .env file, which is going to contain my top secrets. And now I'm going to create this as a repository. So in the source control tab, I'm going to create repository. I'm going to create an top secrets. And now I'm going to create this as a repository. So in the source control tab, I'm going to create repository. I'm going to create an initial commit. I'm going to stage everything. To create an initial commit, I'm going to stage everything, and I'm going to publish this branch to a public GitHub repository under my username. So now I should be able to open it up inside GitHub, and you will see both of these things, .env and not so secret. So .env contains all of my top secrets, which I don't want anybody to know about, and this is really, really bad for me. So let's do it properly this time. Let's show you how we should be doing things. So let's go ahead and cd back, and I'm going to make a new directory. Let's call this proper way to git env. There we go. And let's go ahead and open that up here instead. And in here, I'm going to, again, use say we have our index.js, which needs to exist, have some code, whatever it may be. And then we have our next file, which is our .env containing our top secrets. And now what I'm going to do is actually create my git ignore. So it is simply .git ignore, one word, no spaces. And then I'm going to copy all of these things from that repository that GitHub created, paste it in here, save this, and then go to my source control, initialize repository as I have done before, commit, add everything to staging, and then publish the branch to a public repository. Once that's done, let's go ahead and open it up in GitHub, and you can see that thankfully this time I didn't have to remember to remove my .env or to remove any of the other things because my git ignore already tells me don't upload these terribly secret things. And that means I don't end up with somebody stealing my API keys, which is very important. So let these stories serve as a warning, and remember to always think about adding a .git ignore file whenever you start thinking about using Git, which should be at the very beginning anyways. In this lesson, you've seen how we can use the .env package to add files in the .env file to the local variable, but I want you to have a little go practicing this. If you take a look at the other part of our code, which really should probably be in environment variables, is our database setup. Now, normally your database would not be localhost, it would be hosted remotely. So anybody with the database access, the username and the password would be able to access that database, which is not what you want. So let's prepare for this by switching out the user, the host, the database, the password, and the port all into environment variables. See if you can remember how to do this, and we'll run through it together. All right, so remember that every single new environment variable has to go on a new line. And I'm going to paste in something I made earlier just to speed things up a bit for you. And I'm giving a description. This is PG Postgres, user, host, database, password, and port. I've saved each of those values as a string, no spaces anywhere. And now I can go back into my database and replace all of this plain text in here with process.env. In this case, it's PG variables. See if you can remember how to do this, and we'll run through it together. All right, so remember that every single new environment variable has to go on a new line. And I'm going to paste in something I made earlier just to speed things up a bit for you. And I'm giving a description. This is PG Postgres, user, host, database, password, and port. I've saved each of those values as a string, no spaces anywhere. And now I can go back into my database and replace all of this plain text in here with process.env. In this case, it's PG_user. And you can go through that process for the rest of the lines. So now, if somebody looked at our index.js, they would say, wow, there's all of this secret information that I can't get access to. I don't know what your password is. I don't know what your session secrets are. This doesn't tell me anything that I can do anything bad with. And that's exactly what we want. So hopefully you will have seen how environment variables work. And if you're working with any project which requires a API key, especially one which is paid, remember this lesson and come back to it if necessary. In the next lesson, we're going to get back onto upgrading the security level of our website. And instead of storing users' passwords ourselves, having to try and make sure people don't hack into our database, encrypting, salting, hashing, all of that, we're going to put all of that responsibility onto a big company like Google. So we're going to learn about Google OAuth. So for all of that and more, I'll see you there.
J'ai créé un compte pareil, donc on va juste suivre. Je vais créer un compte sur un projet qui s'appelle My First Project. Donc, ouais. On va juste suivre les étapes suivantes.
Hey guys, in this lesson, we're going to be upgrading our authentication one more level. And this is something that you can either have alongside your previous local strategy, where you allow people to authenticate using username password or email and password, and you have this alongside, or as some modern websites do these days, they don't actually even allow people to register using username and password or make it really, really small so that people mostly go for the social logins. Now, what exactly is OAuth? You might have heard of this term, but all it is, it's simply an open standard for token-based authorization. Now, what did all of that mean? Well, let me explain. So you've heard of Facebook, right? But let's say that we're building a different web app. Let's say we're building a social network that's going to be the new Facebook, and it's going to be called Bracebook. And Bracebook is an awesome social network for people who have braces. Now, when you're a new user who's signing up for Bracebook, you probably won't have any friends in the beginning, right? And nobody likes a social network where you have no social connections and nobody wants to feel like they have no friends. So what can we do as the developers of Bracebook to make this process of joining our social network a little bit easier? Well, we can ask the user for permission to access their Facebook account and see which friends they have on Facebook are already users of our service, Bracebook. So now, once the user sign up, they'll already see that 3 of their friends are already on Bracebook and they're ready to get started in a new life of socializing with their Be Braced friends. Now, how would this work exactly? Well, on our login page, we can ask the user to sign in either manually, where they don't get the benefits of instantly connecting with their friends who have braces, or we can get them to log in with Facebook. And in this case, what would happen is we would make a GET request to Facebook, asking them for this user's friends on Facebook. And Facebook would return with a post request with that list of users and emails. So this might be a really simplified version of that. It's just a straight up table of this particular user's friends on Facebook and all of their emails. So then this gets passed over to our server where we can compare it against our database of users and see whether if we have any matching users who have the same email addresses. So now we know that for this user, we have 3 friends of theirs who are already on Bracebook, and we'll be able to automatically add them as a friend onto Bracebook. And it's also a similar scenario if you were signing up to LinkedIn, for example. If you couldn't be bothered to type in all of your contacts' email addresses to find on LinkedIn and add them individually, then what LinkedIn might do is it asks you to log in via Google, and it will look through all of your contacts on Gmail in order to add them automatically to LinkedIn. So by using OAuth, we're able to access pieces of information on these third-party websites, such as their friends' emails or their contacts on Gmail. But in our case, because we're talking about authentication and leveling up the security of our authentication, another really big benefit involves delegating the task of managing passwords securely to these companies like Facebook and Google. As we mentioned before, every day or so, yet another company gets hacked. And these companies tend to be kind of low-tech companies that are not Facebook, Google, Amazon, who are really known for having great engineers, great teams, who are able to implement all of these levels of security for the authentication on their website. And they probably have thought about hashing and salting passwords or other data that they're storing. But there's more. There are things such as not only salting the passwords, but also peppering the passwords. Some companies also encrypt the entire database containing the hashed passwords and have a wide array of complex mathematical solutions to keep their user passwords under lock and key. Now, as a web developer, we could implement all of those things that I just spoke about and address all of the edge cases, but it would take us a lot of time and a lot of development hours. So why not simply delegate this task to a large company like Facebook and Google? So then every time we log in our user, we simply ask them to log in on Facebook, and Facebook will then authenticate them using their own secure methods. And once that's done, Facebook sends us back a message saying this user is authenticated, they're a real Facebook user, and they have got their correct username and passwords. So go ahead and authenticate them as well. And that will make our lives a lot easier. We'll have a lot less liability. And this is the way that you're seeing a lot of websites going, where they only have third-party login, like login with Twitter, Facebook, Google, GitHub. But in order for us to be able to do all of this, we need to learn about OAuth. That is the glue that binds all of this together and makes it actually tick. Now, what exactly is special about OAuth? Because there's a lot of other open standards that does something similar to this, but OAuth is quite special in 3 ways. The first way is that it allows you to grant a granular level of access. What does that mean? That means that when your user logs in with Facebook, you can request specific things from their Facebook account. So you could say that for my app, I only really need their profile and email address. But say if you were Tinder and you wanted to know who all their friends were so you don't accidentally match them up, then you might want to know also their list of friends. So this is what I mean by granularity. The app developer can determine what kind of data do they need from the user's Facebook account and request those accordingly. Now, the second thing about OAuth is it allows for either read-only or read and write access. So in the case of Facebook, this means that you can either ask them to just retrieve pieces of information about their Facebook account, so what's their name, what's their email, who are their friends, or you can ask for write access as well. Say, for example, in this case, if WordPress wanted to be able to post to Facebook on this user's account, then they will need to ask for read and write access. And the third thing is that the third party that you're using to authenticate your users should be able to revoke access at any point on their website. So that means if you're authenticating with Facebook, the user should be able to go into their Facebook account and deauthorize the access that they granted to your website, say Bracebook. And they don't actually have to go onto your website where maybe you're less keen to give up this access. So now that we've looked at what's special about OAuth, the next thing to talk about is, well, how does it actually work in reality? So the first step is to actually tell this third party, be it Facebook, Twitter, or Google, about our web application, because they don't know about us, right? So we have to set up our app in their developer console, and in return, we get what's called an app ID or a client ID. And we, or our website, is then the client, which will make the request to Facebook to authenticate our user. Now, once you've set up your app, the next step happens when the user tries to log on to your website. So when the user hits up bracebook.com and they want to authenticate, we give them an option to log in with Facebook. So once they click on that option, then we'll take them to the actual Facebook website so that they are seeing a familiar interface, a trustworthy interface, and they'll log into Facebook using their Facebook credentials. And without OAuth, what we would have to do is to ask the user, hey, what's your login credentials for Facebook? Can you give me your Facebook password? Nobody wants to do that. That seems super sketchy and really insecure. So OAuth makes that step a lot easier because it gets them to log in on the website that they actually trust, which is Facebook, right? Something that they've been using for a long time. Now, once the user logs in on this third party, then they have to review the permissions that our website is asking for. So, for example, you might want your profile and email address, and they review that and they're like, okay, I'll grant that permission. So now that they've granted the permission and they've successfully logged in on Facebook, then our website will receive an authorization code from Facebook. And this allows us to check to make sure that the user actually successfully signed on to Facebook. They have the right username and password. So we're now able to authenticate them and log them on to our website. But if we wanted to go a step further, we can also exchange our authentication code for an access token. And when we receive that access token from Facebook, we would save it into our database because this is the token that we can use if we want to request for pieces of information subsequently. This access token is valid for a lot longer than the authentication token. So the way you should see it is that the authentication code or the auth code is kind of like a ticket, right? A ticket that you're going to use once to enter the cinema. But the access token is kind of more like a year pass, and it comes with benefits like backstage access, where you get to request pieces of data from Facebook, including their friend list or their username or their password, whatever it may be that they granted you permission to access. So the auth code is what we need to authenticate the user that they successfully managed to log in through Facebook. And the access token is what we'll use to access pieces of information that are stored on that user's account on this third party's website, for example, their email or their friends list. All right, so enough theory. Let's get started implementing it and adding login with Google to our website. Now, hopefully you haven't skipped over the previous text lesson where we showed you how to set up the Google OAuth credentials. You'll need those, and it's very, very important that you follow it step by step and get it to work. Hopefully, if you have completed that though, you will have filled out your .m file and you would have replaced the placeholders in the Google Client ID and Google Client Secret sections. And once you've done that, then we're ready to go into our index.js and start writing up some code. You follow it step by step and get it to work. Hopefully, if you have completed that though, you will have filled out your .m file and you would have replaced the placeholders in the Google Client ID and Google Client Secret sections. And once you've done that, then we're ready to go into our index.js and start writing up some code. Now, hopefully you've already run npm install on this current project and all of the modules are installed. Now, the only new module that we've added into this project, in this upgrade, is the Passport Google OAuth. And this is going to allow us to create the Google login strategy. So we can import the Google strategy from the Passport Google OAuth 2 module, and we can go ahead and configure it just below our previous. We can import the Google strategy from the Passport Google OAuth 2 module, and we can go ahead and configure it just below our previous passport.use. So this is our local strategy, and just below it, we're going to say passport.use, and this is going to set up our passport authentication middleware. And this one is going to be a Google-based strategy. We're going to first give the strategy a name, which we'll call Google. And then we can go ahead and create the actual asynchronous function. And then we can go ahead and set up our new Google strategy. The first thing in this strategy is a set of options, and that includes the client ID, which is going to be set from the process.env.google_client_ID. Let me just double check that I've spelt that correct. Yep, I think that's pretty much the same. I'm going to copy the next line so I don't have to type it out. And the next one is called the client secret. Now, the spelling of all these things matter a huge deal, so try to make sure that you haven't got anything that you've made a typo here on. And if in doubt, you can always check the solution file for exactly how it's meant to be spelled. And then we have our callback URL, which in our case, if you remember previously, we had set to http://localhost:3000, and then it's /auth/Google/secrets. And then finally, we need to add something called the user profile URL. And this is actually found right at the bottom of the file. And this is the one that we're going to use to be able to get hold of the user's profile information. And there you have it. We've now set up all of the settings. So let's add a comma. And now let's add the callback function, which gets triggered once the process succeeds. So once they actually manage to log in with their Google account. There's something called an access token, which we don't actually need to use. There's also something called a refresh token, which we don't need to use. It's something that can help us keep that user signed in or track their session as we go along. And then we have something called the profile. And finally, that thing that we use a lot in Passport, which is the callback. Now we are in the same section as what we've got here, and we can now get hold of parts of the Google profile. And for now, what I'm going to do is I'm just going to console log that profile to show you what it contains, and we're going to try and get this login page to trigger. So for that to happen, we of course need a get route to do that. So back. Now we are in the same section as what we've got here, and we can now get hold of parts of the Google profile. And for now, what I'm going to do is I'm just going to console log that profile to show you what it contains, and we're going to try and get this login page to trigger. So for that to happen, we of course need a get route to do that. So just below the end of the other get routes, I'm going to write a new app.get. It's going to be hit up when the user clicks on the new sign up with Google and sign in with Google buttons in our login and register.ejs. So it hits up /auth/Google. So it's the same for register and login. We want them to both hit up the same route. And then we're going to use the Passport middleware. So passport.authenticate, and then we're going to specify the strategy we want to authenticate with. And remember, we set up the authentication down here to be called the Google strategy. So we're going to use that right here. So passport.authenticate, the strategy we want to use is the Google strategy. And then once that's done, then we can go ahead and add in some options. We're going to say what are the things that we need to get from this login, and it's going to be the scope. So this is an array. We want their profile and we want their email. So adding both of these things in will mean that when the user logs in, we'll tell them we're going to try and grab hold of your public profile and your email. Hope that's okay. If they consent and they log in, then we should be able to receive it down here. And it should go into this strategy because it's called Google strategy and we specified it here. This is a good point to note that you probably noticed previously that when we authenticated on the login, we use the Passport local authentication method. And this is an optional thing. If you only have one strategy, you don't actually have to name it because they're all the same. But in our case, because we now have two strategies, it's a good idea to add the word local for our local strategy just before the new strategy gets created, and Google for our Google strategy, so that when you run the middleware and you say passport.authenticate, you can specify which strategy the code should go into. Should it go into the Google strategy, which is here, which is going to console log the profile, or should it go into the local strategy, which is going to console log the username from the form submission. And you'll be able to see this is how these different blocks of code actually gets triggered. And this is kind of behind the scenes how Passport works. Let's give this a go and hopefully it works. Let's go ahead and start up our server and go to our register screen and click on this new button, sign up with Google. And now I've got the classic Google sign-in screen, which I thankfully didn't have to code up. And go to our register screen and click on this new button, sign up with Google. And now I've got the classic Google sign-in screen, which I thankfully didn't have to code up. This all comes from Google. And then I'm going to click to the account that I have a Google sign-in with, and I'm going to go ahead and sign in. Now, notice it says that Google hasn't verified this app. Now, app verification can take anywhere between 1 month and 3 months, so we're just doing a tutorial, we're keeping it in localhost. It doesn't actually matter for us in this case. If you're developing a production app, then you'll need to wait for that process and submit it on that console platform that I showed you in the previous text lesson. So in our case, what we're going to do is we're going to click on continue. And if you accidentally clicked on the right button, you can always go back and just click on it again. So now it's going to say that signing in to this application called Secrets, and by continuing, Google will share your name, email address, and some other profile things with this application. We built the application, we are receiving the information. So in our case, it doesn't really matter. We're just doing some testing. Let's click continue. And now it's trying to make a GET request to this location, which we haven't written in our server yet. So let's go ahead and do that. Let's go back to our code, and below the previous app.get, let's add /auth/Google/secrets. And in this case, we're going to run passport.authenticate using the Google strategy. And we're going to add some options, just like what we've got down here, the success redirect and the failure redirect. So success redirect should, similarly as login, go to secrets, and the failure redirect should go also in the same vein as the code below, go to login. Let's save that code and let's try it again. Let's go back, run passport.authenticate using the Google strategy. And we're going to add some options, just like what we've got down here, the success redirect and the failure redirect. So success redirect should, similarly as login, go to secrets, and the failure redirect should go also in the same vein as the code below, go to login. Let's save that code and let's try it again. Let's go back to our register page, sign up with Google, click on the account, continue, continue. And now if we take a look inside our terminal, you'll see that that person's profile has now been printed into our console. So it includes things like their picture, their name, their email, and a whole bunch of things that they allowed you to have access to, which we can then save in our application. That's the next part of the code that we're going to do. What happens when we end up inside this callback? How can we save their data into our database and be able to identify them in our system? First, we're going to add a try-catch block, as we have previously done. And then we're going to use a await to make a DB query. And we're going to use the command select all from users where email is equal to $1, and the email is going to come from that profile that we printed out just now. So it's profile.email. And just to verify, you can see that we printed out the profile, and indeed inside the profile there is a property called email, which is what we need to save into our server. So the first thing we want to check is to create a result that checks to see if that email already exists in our database. Now we can use an if statement to check if result.rows.length is equal to 0, in which case that means we don't have any users by that email in our system. Then we're going to create a new user. So we're going to, again, use await db.query, and the query in this case is going to be an insert query. So we're going to insert into the users table, and we're going to add to the two columns, email and password. And the values that we're going to add are going to be $1 and $2. And let's add that at the end. So $1 is the email, which is easy. It's profile.email. Now, what you want to set as their password depends on you. So some people, because there is no password, we don't get the user's password from Google, and that's the whole point of it. We don't have to store it. Want to set as their password depends on you. So some people, because there is no password, we don't get the user's password from Google, and that's the whole point of it. We don't have to store it. So some people store their user ID to identify them. Some people store a word such as Google, just so that when you look through the database, you know why it is they don't have a suitable password. It's because they are a Google sign-in user. So it really depends. In my case, I'm going to set it as Google to be able to differentiate them from the local login users and to make sure that they don't then try to log in with the same email that they logged in using the Google login. But it really is something that is up to you individually. Now that we've created the new user, we can now finally use that callback, and we're going to pass null for no errors, and then we're going to pass the new user into that callback so that when we serialize and deserialize that user, we can then access it in the same location when we go to the secrets. So that request.user gets populated with the details that we add in from this new user that we created. Remember, with the local login strategy, we get hold of the user that's stored in our database and add it to the session. And in our Google strategy, we get hold of the new user that we've just added. And because this actually is the result from this query, you'll remember that it's not just the result, it's actually .rows at position 0. Next, we're going to add a else statement, and this else statement is in the case where we already have the existing user. And that's because this is if result equals 0, then that means that user is new and we add them in. But otherwise, that means the user already exists and we can tap into the result in order to add to the callback. So we don't force them to log in again. We also say there's no error, and we simply tap into result.rows and we grab the 0th one as the user that we register. So now finally, we can use our catch to catch any errors, and we can use a callback to pass that error through. And that is all we need to do in order to set up our Google strategy. Now, there's quite a few moving parts in this, so I would not be surprised if you made a typo or a mistake or order or something is wrong. So what I recommend you to do is to use the VS Code compare just to make sure that you haven't made any typos or any issues. So you can do this by right-clicking on the current file that you're writing, so your index.js, and select this line, select for compare. This is your file, and then I want you to right click on solution.js and select this line, select for compare. This is your file, and then I want you to right click on solution.js and select the other one, compare with selected. I know it's confusing, but just listen to me a few more times and you'll probably understand what's going on. But this way we've got our index.js on the left side, the solution.js on the right side, and you'll be able to see any of the differences between your file and the solution file. So here are some things that might be different. If in your file there's something extra, then you'll see it show up as red, meaning this is deleted in the solution file. Or if there is something extra On the solution file, you'll see it as green, which means this is something that's extra compared to your file. Now, some of these things might just be an order kind of thing. For example, if I change the order here to here, you'll see it show up as red here. Line 10 is deleted, but line 4 is added. And you can read through this just to see what the differences are and be able to understand what's actually going on. And the most important part is, of course, this app.use Google strategy. So check to see if you have, there shouldn't really be anything that's different compared to the solution code in your case, because we're using process.env, so we're not taking into account any of these unique aspects that's in your environment variable file. So hopefully you can match up and find all the issues. This is a really neat way that I hope will help you. But otherwise, we are ready to test things out. Let's hit save, and hopefully Nodemon is still listening to our changes and updating things. Yep. So let's go to our server and let's go to register, sign up with Google. And if we check our database and update it, you'll see the new user has been added in. So this is the email and this is the password that we set for them. And now if I go into secrets and I refresh it, or I close down the browser and reopen the browser, you'll see it's still cached my session, even though I'm logging in with a Google login. Now, the final thing we want to do before we finish is we want to make this logout button work, because otherwise we can't test our other login methods, but also it's pretty useful for our regular users. In Passport, the logout method is really simple. You'll see if you go into the secrets page, which is where the logout button exists, it goes to /logout, a GET request that we can create in our server. Let's go ahead and create another app.get, and we're going to say /logout. And here we're going to set up our request, response, callback, and we're going to tap into the request object, and there's something in there that's actually called logout. Now, it's important that you choose this one, which is all lowercase, rather than this one. And then we can go ahead and add our callback. So error, and inside here we're going to check if there is an error, in which case we will simply just console log the error. And otherwise we're going to res.redirect to /. So the home page is where we're going to go after we log out. If you've never seen this syntax before, this is simply just a one-liner. So we've got an if, we've got the condition, and then we've got what should happen if that's true, all in one line. And let's go back to our secrets page. Let's make sure that we can actually sign in. And now if we click log out, it takes us to the home page. And if we try to go to secrets again, it's not going to let us. So there you have it. We've got login with email password, we've got login with Google, and we now have logout. All that's left to do is for you to be able to show a secret for each user, and for each user to be able to add their own secrets. And that will complete this project. So for all of that and more, I'll see you on the next lesson. Hey guys, we finally gotten to the point where we can actually finish off all of the features for our secrets application. We've done a lot in terms of building up the authentication levels, making sure that it's secure, giving users lots of different ways of signing in, and discovering a secret. Now, this secret at the moment lives in the secrets.ejs file, which is just a piece of text at the moment. And you can see it if you go into the views secrets.ejs. It's just a paragraph element. Now, we're going to change all of that. We're going to use EJS to insert a user's secret. And the user should be able to submit their own secrets. There is a page called submit.ejs where we can allow users to make a post request to a route in our server, which is at /submit, in order to submit some text that corresponds to their secret. And that secret then will get displayed here, and we'll keep it in our database in the same users table, just to keep things simple. So your job is to complete this as a challenge by yourself. The first thing that you're going to need to do is to add a new column to the users table, which has a name of secret, and it's going to hold data of type text. And once you're done, the user should be able to log into the website and click to submit a secret. This brings up the submit.ejs page, and the user can type a secret. For example, what are some of my secrets? I'm scared of clowns, which is a weird one. But also, despite learning surfing for so many years, I'm still kind of bad at it, which is a secret. Please don't tell anyone. And once I hit submit, I'm going to save that secret into the database under that user in the same row as that user. And then when secrets gets re-rendered, that secret gets displayed here instead of the default message. So that is essentially the functionality that we want. So you could keep something secret from other people, and you would be able to authenticate yourself as a user to be able to add it, and then you need to be authenticated in order to view that secret. There are a number of things that you need to do to achieve this. The first to do is, of course, adding in that column. And if I update this users table, refresh it, you'll see that brand new secret that I added just now going in right there. And if you go ahead and open up the extracted 9.6 secrets project and you take a look through the index.ejs, you'll see that I've put in some to-dos for you. There's 3 to-dos here. You need to update the get route for secrets in order to pull in the secret that belongs to the user if they have one. And then you need to think about how to create a get route so that we can show people the submit.ejs page. And think about how we should only allow authenticated users to view that submit a secret page. And if they're not authenticated, they should be asked to log in. And then finally, we need to create the post route for submit so that when a user does submit their secret from here, that secret gets saved in the database and replaces anything that exists there before, and finally makes sure that all of that process went through smoothly. Now, a couple things to note. If you get confused, the SQL command that's required to update the column is in here. But of course, given that you've already done the database module, you should already know how to do that. And this is a good point to test your knowledge. And even if you don't remember, I recommend Googling before looking at the solution. See if you can figure it out first. And the solution code, which we'll run through together, includes all of the to-dos that need to happen before this code is going to work. Final reminder, in the .env file, you need to replace your client secret and your client ID with your own Google client ID and secret. That way, the Google login part will actually work. So you should have this from the previous lesson, and you can simply go and paste it in. So now I'm going to leave you to it in your own capable hands to struggle and to figure things out and see if you can get this to work and finally complete the secrets project. I'll wait here, and once you come back, we'll talk through the solution together. All right, so the first thing I'm going to do is to put in my own values for the Google Client ID and Google Client Secret. Next, I'm going to go into the secrets.ejs page and I'm going to update it so that instead of having that plain text, I'm replacing it with a EJS tag. So this is the angle bracket %equal, and this is going to be sent in here programmatically. If you don't know what I'm talking about in terms of EJS, in terms of partials, then be sure that you haven't skipped a module on that in the course. So now that I've done that, I can close that file down and I can focus on the to-dos here. The first thing I'm going to work on is creating a get route so that we can actually display the submit page. And this is going to be triggered when the user is on the secrets page and they click on this button, submit a secret. That's going to hit up the submit route. And this is what it looks like in the browser. So this is the button we're going to hook up to our server. So we've got our app.get, submit, and then we're going to add our callback, recres. And then inside here, we're going to think about how we're going to prevent an unauthorized user from seeing the submit page. So we know that the submit page is under submit.ejs, but we should only res.render this if they are already logged in. But thankfully, we know from our secrets route that we can simply use the request object to check to see if the user is authenticated, because we're using Passport and because we're using sessions and the user's detail is saved in those requests that gets passed around. So we can do the same thing and say if request.is authenticated, well, in that case, we're going to res.render submit.ejs, but otherwise we're going to res.redirect and take them back over to the login page, like so. That is that to-do done. So I'm going to check that off. Next, I'm going to set up the post route for submit. Once the user is on this submit page and they type a secret, when they hit that submit button, it's going to hit up our post route in our server because the form action goes to /submit, making the request post. So we have to write this right here. And I'm going to write a app.post and the route is /submit. And then we add our request response etc. And now inside this route, we need to handle the submitted data and add it to the database. We've already got body parser enabled in this, so we can simply set the secret to a const as the requests.body. And if we check here for that input, what is the name of that input? Well, it's just called secret. So request.body.secret is going to equal whatever the user types in here. And then we're going to submit that into our database. Now, how do we know under which user to submit this secret to in the database? How do we know that it's this user that's logged in and we need to put the secret under their record? Well, remember what I said previously about using Passport. One of the great benefits is we can get access to the user through request.user. And this is because when we do our login local strategy or when we do our Google login strategy, in both cases, we return the user and all of their data in the callback, which gets serialized and then deserialized so that we can access them right here under request.user. So if you want, you can console log and see the result of that. Now, I know that I can simply access the request.user.email and query it in my database. So I'm going to do a try catch. And I'm going to use my await and then db.query. And the query that I'm going to use is update users. So update the table called users and set the field that's called secret to equal $1. And I need to make sure that I'm only setting this for one user. And that's where their email is equal to the second input $2. So now let's put in $1, $2. $1 is going to be equal to the secret and $2 is going to be the request.user.email. Now, because this is asynchronous, let's go ahead and change this to async so that that works. After all of that's done, we're waiting for this to finish, hence the await. And after that, then we go ahead and do res.redirect and take the user to see their secret. So we're going to redirect them to the secrets route, which is, of course, the get route, which means they get to view the secrets, which is, of course, the get route, which means they get to view the secrets.ejs, which is, of course, the get route, which means they get to view the secrets.ejs, which we have one more to do to pull up their secret from the database. So we've saved all of this and we have caught our error, and I'm just going to, for simplicity's sake, console log that error as my error handling for now. So I'm done with the second to-do, and I'm going to replace my to-do with a comment for you so you know how to find it. And the last to do here is to change the app.getRoute for secrets so that we actually pull in the user's secret so that we can render it in the secrets.ejs. Remember, we already changed our secrets.ejs so that it now uses a EJS tag to receive under secret. We have to get hold of that by passing it in the same sentence as we do our res.render. Our res.render happens, and then we get to add some things to pass over. In our case, it's called secret. And what is the secret that we're going to pass? Well, we're going to have to get a hold of that from our database. Again, we're going to do a try catch. And what we're going to try to do is to create a const called result. We're going to do await, and then we do db.query. And the query that we're going to make is select the column called secret from the table called users, and then the condition is where email equals $1. And the email is again going to come from our Passport authentication request.user.email, and it's really neat being able to access the user's details at any point because of this whole Passport session thing that we've already set up. So that's pretty neat. And because we're using await, let's go ahead and change this to async as well, and make sure that request.user.email is in a array. I think I missed that out just now, so make sure you check yours. So once we get the result, we're going to console log the result just so that you can see it. But I know that it should contain a secret for the user that I just logged in. I'm going to go ahead and continue to fetch that secret out of the result. So it's going to be result.rows at the row 0, and then it's under the column called secret. So this should allow me to access the secret. If the secret exists, we're going to go ahead and do what we plan to do, which is to res.render that secret and pass it over like so. But what if it's a user who doesn't have a secret yet? They just joined the website, they don't have one. Well, in this case, we're going to res.render secrets.ejs, and we can put in the default, which is Jack Bauer is my hero. Alternatively, you can just have a placeholder. You should submit a secret. It can be anything that you want. And finally, I'm going to catch the error here with just a console log. And that should complete this to-do. Let me put a marker here. And now let's go ahead and try it out. Now let's go ahead and try it out. So I'm going to log in as my user, and you can see that the secret that I submitted previously still shows right here. I'm going to click on submit a secret, and let's try a new one. Click submit and goes to test. Let's try logging out and logging in again, and you can see it still persisted because it's pulling it in from our database. So I hope you had fun building this application and in the process learning all about authentication. I've kept this project as simple as possible so that we can focus on the important things, which is already complicated enough. But this is a good time to try practicing what you've learned by applying these authentication steps and knowledge to a previous project of your own. So have a think about what you might want to do. Brainstorm some projects, and if you build anything cool, as always, post it in the Q&A. I would love to hear about it. Now, very often I hear students ask me about how can I become a freelancer? I want to work in Bali, or I want to travel, and I want to be able to, at the same time, work as a freelancer. One of the best ways to get started is to build a portfolio and to build up a list of clients who can vouch for you. Because if you want to get that top gig right at the beginning, then it's going to be very, very hard without some references, without something to show for. So the first thing I recommend students do is to go onto a website like Fiverr, where people are not paying very much for any sort of service, but, to practice working with a client, to figure out what it is that people want, to establish how you can better communicate with your clients and make them happy and build the things that they want. So even though you're not getting paid a lot in the beginning, at least you're working with real projects and real people. And as you build up your skills, as you build more projects, then you'll be able to go to websites like Upwork or Guru or Freelancer and be able to offer your services for slightly more. Basically, don't shoot for the moon right at the beginning. Instead, build up your reputation and build up your skills while you're giving your clients excellent service for not very much money. And this way, within a year or so, you'll have enough projects to show off and enough clients will vouch for you. Then you can shoot for the moon.
Hello, hello, hello. Là, on vient de terminer la section, je vais voir ensemble avec vous, la section 35. Mais il y a quelque chose qui m'a intéressé ici, c'est qu'elle dit, ce livre-ci, où elle explique que lorsque vous avez étudié un peu comme celui-ci, vous pouvez commencer en tant que freelanceur pour des entreprises ou des clients qui paient pas très cher, mais ça vous permet de bâtir votre portfolio. Et ces clients-là, vous pouvez les trouver facilement en, euh, par exemple, oui, elle a dit ici quelque part, Bali, travailler à Bali, et ça vous permet de voyager à travers le monde en tant qu'indépendant. Donc, vous pouvez constituer justement votre portefeuille de liste de clients. Et ces clients peuvent facilement se porter garant pour vous, si vous réussissez à les déboucher. Et au fur et à mesure que vous bâtissez votre portefeuille, vous pouvez maintenant atteindre un niveau où vous pouvez proposer vos services, par exemple, à votre compte, ou des freelancers. Là, vous pouvez trouver des services pour un prix un peu plus élevé. Donc voilà pour ce qui est de la section 35. Donc, il nous reste plus grand chose. Il nous reste Il y a quand même un bon paquet de choses à faire après. Mais il ne nous reste pas grand-chose, hein. Il nous reste 36 à 44. Donc, en principe, le plus gros boulot, c'est React.js, qui est un cours de 8h30, mais en accélérant un peu le cours, on peut le finir facilement en 7h30. Je vais commencer tout à l'heure et euh, peut-être je pourrais finir demain ou après-demain. Après ça, on pourra faire une autre section un peu plus longue, deux sections un peu plus longues, qui sera de créer, comment créer notre propre crypto token et notre site de marketplace. Voilà. Donc, voilà un peu ce qui est, ce qui reste à faire. Rendez-vous à la prochaine vidéo.